Okay, we are now at section, oops, it would help if I get the right pen here, section 8.4, part B. And I left off with introducing what to do with a calculator, and I want to start again with that concept, and that is that we're going to use an app key to do a binomial probability. Now, before, we had to figure out what was the probability of it not being a success. In other words, because we know a binomial is success or failure. And I'm going to do it both ways in these lessons so that you can have a good handle of the mathematics as well as understanding the technology. All right. So remember, we'll be doing second bars, which is a distribution in a new window for statistical app. Then we're going to arrow down to A, binomial PDF, if it is an exactly one value, or B, binomial CDF, if it is less than or equal to or greater than or equal to a value in the probability structure. So it's very important, number one, that we know the trials. Number two, we know the probability of success. And the third one is the whether it is exactly more or less than. Your instructor can't write worth a hoot. A value. Okay, so we have to know those exactly or more than or less than a value. So let's do this problem. I'm going to move that up. I hope you wrote it down on your notes so we can get started. A survey finds customers are overcharged by a price scanning system on an average of 1.95%. Well, as a decimal, that would be 0.0195, because we need to have that decimal representation of percent. Suppose a customer purchases 14 items. So our N is 14. Find the probability the customer is overcharged on at most 2 items. All right. So in this case, this probability is going to be 1 minus, and it's going to be the probability of 2 plus the probability of 1 plus the probability of 0. All right. Because at most, oh, no, it's just that. Sorry, it's not 1 minus. Just that. Okay, so let me structure it as our problem set. So the way we would write it would be in the combination form. So here we go. So we would have 14, choose 2. And then we'd have our success as the being overcharged is not success, but that's what we're looking at. Do the 2. And it would be, now we need the P minus, the 1 minus P to get the failure. And that would be 1 minus the 0.0195, which gives us 0.9 9805. Okay, so that would give us the 0.9805, because if this is 2, then this is 12. All right, so I got that. Plus 14, choose one of the same thing, 0.0195 to the 1 times the failure, 0.9805 to the 13, plus 14, choose 0 of the success, in this case, that they overcharged you, to the 0 times 0.9805 to the 14. All right. So this is going to be the probability at most. At most. Here we go. So I'm going to do it on my calculator like we've done before. I'm going to clear everything. I'm going to do the 14 math, PROB, number 3, and I'm going to choose at most 2, the first one. And then I'm going to put in parentheses or times. I can put times, but I do like parentheses. 0.0195, close parenthesis, up caret, and this one is my 2, crossover, multiplied by parenthesis, 0.9805, close parenthesis, up caret, and this one is 12. All right, so now I have 14 of my trials, and I get this value. Decimal, and I'm going to do 4 decimals. So 0273. Okay, now remember what we did, second entry, and we're going to come back to our condition, and we're going to put 1. And on the exponent, I'm going to put 1. And I'm going to increase the 12 to a 13 and enter. And I'm going to get 0.2113. All right. So now I'm going to do the next one, which is the last one, second entry. I'm going to go forward. I'm changing the 1 to a 0. I'm sorry about that. And go back and make it a 0 because we can have none and still comply. So that's a 0. And to a 0, we know that's 1, but we want to just do our structure so we don't get confused. Notice that this is going to be the last one, the 14. And I'm going to get 7590. 7590. Okay, so now I'm going to add them. Make sure I entered right. 0.0273, 0.2113, 0.7590, and I hit enter. And I get the value of 9976. Now we're going to do it by calculator. All right. So in this case, we want everything less than, and the calculator will get on a cumulative is sum of all probabilities less than or equal to the value. So it gives you everything less than or equal to, not greater than, not above, but below. And that's going to be very important. So we want at most 2. That means less than or equal to. So we're going to go to second vars, and this makes it distribution, second distribution, and we're going to arrow, oops, that should be arrow down. Arrow down to, and we want cumulative, so that is the B. And we're going to enter our trials, which are 14, our probability, which is 0.0195, and then how many less than or equal to we want, and it is 2. All right, so now that we have that, let's use my calculator. I'm going to clear everything. I'm going to go second vars, which is third row, fourth key, and I see a window of statistics. I'm going to arrow down to B. There's A, and there's B, and I enter, and it says normal CDF. Okay. And then I'm going to enter the 14. Now, if you have an older model, you just put a comma on the next entry, and the probability is 0.0195 that we're looking at as success, and 2. All right. All right. So, sorry. All right. So let me make room here, and I'm going to paste. All right. So what I have here is, well, it's not, I'll just go further down. Sorry about that. What I have here is this answer. Now notice we had the calculator gives us decimal 9977. If you are one or 2 digits away from the answer you did manually, it's okay. The calculator will accept. Because it's an app. It'll accept a small variation of the 4th digit. But the first 3 must always be the consistency. But you will be okay if you use a calculator for your homework. All right, well, let's try another one. Here we go. All right. We have, according to a survey, 21.7% of the credit card holding families in a certain area hardly ever pay off their balance. Very bad thing. Suppose a random sample of 26 26 card-carrying families is taken. Find the probability at least 4 families. Hardly pay off the balance. All right, so let's think about what the language says, because we talked about it at the beginning of this lesson, because it was important to me that you hear it several times. At least 4, that means we can have 4, or we can have 5, or we can have 6, or we can have, I should have said or in between, because or means to add, 4, 5, 6, or 7, or 8, etc., until we get to 26. So rather than do that many, we're going to say we want the probability of this event hardly pay off balance to be 1 minus, and this would be the probability of every number less than 4. So it would be probability of 3 plus probability of 2 plus probability of 1, sorry, I'm going backwards, and probability of 0. So the calculator is going to be very good at this one. So we're going to do it manually first, and that's because I think it's very important we understand what is taking place, and then go from there. So here we go. We want and I'm going to do the one at the end. I want to focus on this part here. So we're going to want the 26, choose, and we want 3. And we want our success as, oh, I forgot to put that down. Sorry about that. So our success of not paying is 0.217. So 1 minus the probability is going to be point, and is 783. All right. So we're going to have the 0.217 raised to the 3 times the 0.783 raised to the 23 plus the 26 choose 2 times the 0.217 to the 2, the 0.783 to the 24, plus the 26 choose 1, because we're at the 1, of the 0.217 to the 1 times the 0.783 to the, now I have 1, so it's 25. And then I have the 0, which is the 26 choose 0 of the 0.217 to the 0 times the 0.783 to the 26. All right. 26. All right. So this is what I have. All right. So I'm going to do this part first. Okay. And it's easier for me than to put 1 minus in the whole business. And I can give you an answer and it'll look pretty decent. All right, so here we go. Okay, get my calculator out. And that way I can copy as well and do it relatively fast. 26 math, EROB, and I'm going to do number 3, and I'm choosing 3. Side arrow, and we're multiplying by 0.217 up caret 3 side arrow times 0.783 up caret, and that would be the 23. And I enter. And I'm going to get a 4 decimals, 0957. I'm going to do the second one. So I'm going to do a second entry, and I'm going to go all the way to the front and change it from a, sorry about that, change it from a 3 to a 2, reduce that one to a 2, and increase the other one to a 24. Make sure I entered everything correctly. Yep. And hit enter. And I'm going to get 0.0432. Now I'm doing the next one, which is the 1. All right, so I'm going to go all the way to the C and change it to a 1. I'm going to reduce the first success one to a 1 to match, and we're going to change it to a 25 and enter. And 0.025. Sorry about that. 125. Okay, make sure. All right, yes, that's what I have there. So I'm getting closer. And now I'm at the last one with the 0. Second entry. I'm going to put combination to 0, which makes that number a 1. Oop. Make that a 0. And make this one a 6 and enter. And I get 0.0017. 0.0017. All right. So I have now what I need. I am going to have 1 minus this sum. So let's do that. 0957 plus 0.0432 plus 0.0825 plus 0.0017. So I'm going to double check that I entered 0.09570432. Oops, I did an 8, not a 1. So let me go back over here and change that to a 1, a 0.125 and a 0.007. There you go, Alma. All right, so I get 0.1531. Okay, so now I'm going to say 1 minus 0.1531, and I get the probability of 0.8469. And that's what the chances of 4 or more families not paying off their debt. Okay, so now we're going to do it by calculator. So we're going to go to the second vars, which is distribution, but we're going to put 1 minus, second vars, distribution, and we want a CDF. We're going to arrow down to B, binom CDF. And we're going to enter our trials, which was 26 RP, which is decimal 0217, and our value, and it is 3. All right, so here we go. I'm going to do the 1 minus second vars. I'm going to arrow down till I get to the B, CDF, and then I'm going to enter my 26. My P is 0.217, and I want it accumulated to 3 inclusive. And I get 0.869. Look at that. So it comes out to be 0.8470 if I round to the 4th decimal. Both are correct. Okay. So you keep using your rounding rules. You be confident that no matter what, it's going to be okay. If there's a small variation between the manual computation and the calculator computation, the calculator is more exact. That's okay too. Now we're at our last problem, and of course this one is in detail. So let's look at what we have and try to settle this guy. All right, here we go. The probability that a okay, hold that thought. Right. There we go. Just a second. The probability that a part produced by a certain factory assembly line will be defective 0.032 or 3 2/10%. Find the probability that run of 43, so our N is 43, and our P is 0.032. So that says a probability that exactly, okay, our A is probability exactly 3 are defective. All right. So if I did it by hand, I would say exactly 3. So I would say C, 43 C3, and I would have the 0.032 raised to the 3, and then I would have the 1 minus P, which would give me 0.968. Yes, and that one would give me 10, yes, 0.968, and this one is to the 40. And that's all I'd have because it's exactly that amount. And I would do it on my calculator. 032 up caret 3 side times 0.968 up caret 40. Oops, sorry. And enter. All right. So when I do that, guy, I'm going to get 1101. Right. That's the probability of at least 3 defective. Well, if I did it by the calculator, I would have, this is exactly, so it would be binomial PDF, and I would have my trials, my P, and my 3, because that's my X. All right, so I go second bars, and I would arrow down to the A, PDF, enter, and I would put my trials, that was 43, my probability of getting a defective, and I would choose 3. And I would get exactly the same thing. Oh, I put 14. Oh, darn. Let me erase that. 43, oh, 53. Oh, 1. Oh, I didn't copy it. Oh, just doggone it. How did I do that? There we go. Let me go do it again. I had it, just didn't copy it, I guess. Try it again. There it is. 1. Okay, so we got that one. Let's do our B. Our B says probability no parts will be defective. All right. So if we want no parts to be defective, we want our 43, choose 0, none that are defective, of 0.032 raised to the 0, and not defective is the 43. Again, it's a normal PDF. Forty-three, that one, and we want 0. And it is by calculator 2470. If I did it by hand, that would be I think on the hand it came out 69, if I remember correctly. But both work. So I'm going to do our 43 math, PROB, and we're talking number 3, and we're putting in 0 times 0.032 up caret 0 times 0.968 up caret 43. And see, no, I got the same thing. Same thing. So we're good. Sometimes it is exact and sometimes it is not. So the probability, and we're talking the C1, probability that at least one will be defective. In other words, we can have 1, 2, 3, 4 defective all the way up to the 43. So we already know what 0 is. So we're going to say 1 minus the probability of no defective. So that would be 1 minus the 0.2470. And that would give me 0.753. All right. Now, I think that's the last one. Yes. All right. Now, I have done things by hand on almost all of them. And I have shown you the construction, which is very important. Unless you construct this stuff, you won't understand it. And then the third step was the calculator to have ease. Remember about the vocabulary that we did way at the beginning. And take your time with this. It is very easy, but you can make it hard. Thank you for listening. And do your homework now.